Hello students, welcome to the subject of Mathematics 3. Myself Dr. Ankit Acharya, and in today's session we discuss about non-exact differential equation and how we can reducible to non-exact differential equation to exact form. Okay, last lecture in previous lecture we discussed about exact differential equation, and if your differential equation is exact, we can easily find out the general solution of that differential equation. But here non-exact differential equation, okay, reducible to exact form. So in your syllabus there are 4 cases, okay. So we are discussing about from case 1, 2, 3, 4, how we can how we can make non-exact differential equation into exact form. Okay, so we know that our differential equation is this type, m dx plus n dy equal to 0, or sometimes we can convert your differential equation in this form. We know that if exact differential equation, then del m by del y that is equal to del n by del x. But for non-exact differential equation, del m by del y not equal to del n by del x. So in that case we have to find integrating factor. Integrating factor means the term where we multiply your integrating factor in both the side. Okay, your now new differential equation become exact differential equation. Okay, so there is a case one. If del m by del y, okay, del m by, because you already find del m by del y and del n by del x both. So now suppose we find del m by del y minus del m by del x and upon n, okay, upon n here, and suppose this is a function of x only, f of x, okay, f of x, del m by del y minus del n by del x upon n. So integrating factor, what is your integrating factor? This is my integrating factor, e raised to, okay, this is my f of x, del m by del y minus del n by del x upon n. Okay, this is my f of x, and integrating factor is what? E raised to integrating factor. Here you can see that e raised to integration f of x dx. Okay, integration f of x dx. So this is my integrating factor. Okay, and when you multiply this integrating factor in both the side in this equation, okay, so that means right hand side you have already 0. So whatever the term you multiply, right hand side only 0. So integrating factor into m dx plus integrating factor into n dy, that is equal to 0. Yeah, now your new differential equation is always exact differential equation. That we will check and solve one example. Okay, so here you can see that suppose I want to solve this example, solve x square plus y square plus 3 minus 2xy dy, that is equal to 0. So what is your m? M is equal to x square plus y square plus 3, n is equal to 2xy, clear. Now del m by del y, okay, this is my m. So del m by del y is 2y, clearly. Del m by del x is minus 2y, okay. And here you can see that del m by del y and del n by del x, these two are not equal. Okay, del m by del y and del n by del x is not equal. So that's why this is non-exact differential equation. Okay, now let's find f of x. What is your f of x? This is my f of x. F of x is what? Del m by del y minus del n by del x upon n. So 2y, del m by del y is what? 2y minus of minus 2y. So this is 4y. Okay, upon n. N is what? Minus 2xy. So ultimately this is 4y upon minus 2xy. Okay, so y will be cancelled out. Here 2 2s are 4 and 2 will be cancelled out. So minus 2 by x. Okay, so minus 2 by x. So this is a function of x, and now your integrating factor. Okay, integrating factor is what? What is my formula? E raised to integration f of x dx. So e raised to integration minus 2 by x dx. So that is equal to e raised to minus 2 log x. So that can be written as e raised to log x raised to minus 2. E and log will be cancelled out. So x raised to minus 2. So you will get 1 upon x square. Okay, clearly this is your integrating factor, 1 upon x square. Okay, so here you can see that integrating factor e raised to minus 2 by x. So e raised to minus 2 log x. So e raised to log x raised to minus 2. Okay, so that is 1 upon x square. So that means what? When we multiply this equation, okay, this whole equation with 1 upon x square. Okay, so when we multiply this equation with 1 upon x square, so 1 upon, I just write here, okay, 1 upon x square into x square plus y square plus 3 dx minus 1 upon x square into 2xy, that is equal to 0. Okay, so that's why 1 upon x square into x square, so 1 plus y square upon x square plus 3 upon x square, okay, dx, okay, and here minus, because x will 1x will be cancelled out, so minus 2y upon x, that is equal to 0. Now this is your new differential equation, that is always exact, that you can check. Okay, suppose this is your m, so m is what? Now your new m, or we can say m1, okay, m1, that is 1 plus y square upon x square plus 3 upon x square. So del m1 by del y, so that is equal to differentiation of 1, that is 0, 2y upon x square, and differentiation of 3 by x square, that is 0. Now n1 is what? Minus 2y, okay, so n1 is equal to minus 2y upon x, and when we differentiate with respect to x, so because of differentiation of 1 upon x, that is minus 1 upon x square, okay, so that is 2y upon x square, so both are same, 2y upon x square, 2y upon x square, clear? So here you can see that now your differential equation is exact, m1 del m1 by del y, del m1 by del x, both are same, okay, hence the general solution, integration m dx. So now your equation is this, 1 plus y square upon x square plus 3 by x square, okay, so 1 plus y square upon x square plus 3 by x square, integration with respect to x, and because of here there is no term in n1, there is no term which consider only y, okay, because if there is a term in include x, we cannot take this term, okay, so that's why integration 0 dy, integration of 1 with respect to x, that is x, okay, y square plus 3 constant, integration of 1 upon x square, integration of 1 upon x square, that is you can say that integration x raised to minus 2, and that can be written as x raised to minus 2 plus 1 upon minus 2 plus 1, so that's why this is minus 1 upon x, okay, so integration of plus 1 upon x square, they mention minus 1 upon x, y square plus 3 as it is, and when we take LCM, so finally you will get x square minus y square minus 3 and c into x, so this is your final answer, okay. So we just discuss about case 1, if your differential equation is not exact, m dx plus n dy equal to 0, so case 1 we can find integrating factor which is a function of x, and what is your integrating factor? E raised to integration f of x dx. What is your f of x? F of x is nothing but del m by del y minus del n by del x upon n, okay. Now case 2, okay, let's discuss about case 2, del n by del x minus del n by del y upon n, totally reverse, okay. Here we have to find del n by del x minus del m by del y and upon m, okay. This is always function of f of y, okay. It should be function of f of y, not always, but it should be function of only y only. So what is your integrating factor? Integrating factor, that is e raised to, okay, integrating factor, that is e raised to integration f of y dy, okay. So this is your integrating factor, and we have to multiply on both the side. So let's try to one example, y raised to 4 plus 2y dx plus xy cube plus 2y raised to 4 minus 4x dy equal to 0. So this is my m is y raised to 4 plus 2y, n is equal to xy cube plus 2y raised to 4 minus 4x, so del m by del y, clearly del m by del y is 4y cube plus 2, del n by del x is y cube minus 4, okay, because here differentiation of y raised to 4 with respect to y, that is 4y cube, differentiation of 2y, that is 2, okay, differentiation of xy cube, that is y cube, differentiation of x with respect to x, that is 1, y cube constant, differentiation of 2y raised to 4, that is 0, and here minus 4, okay. So y raised to y cube minus 4, here 4y cube plus 3. So del m by del y, that is not equal to del n by del x, okay. These two are not equal, clear. So now you use f of y. This is my f of y, or g of y. You can say g of y. Okay. So the formula is f of y is del n by del x minus del n by del y upon n. So that is equal to y cube. Okay, y cube minus 4. Del n by del x is what? Y cube minus 4. So this is y cube minus 4 minus 4y cube plus 2 or upon m. Okay, so that is y raised to 4 plus 2y. So when we calculate this term, y cube minus 4y cube, so that is minus 3y cube, and minus 4 minus 2, so that is minus 6. So minus 3 will be common, y cube plus 2, and in denominator y will be common, so y cube plus 2. Okay, so minus 3 upon y. So y cube plus 2, y cube plus 2 will be cancelled out. You will get minus 3 upon y. So now what is your integrating factor? That is e raised to minus integration 3 upon y dy. So that is e raised to minus 3 log y dy, log y, integration of 3 by y, that is log y. So y raised to minus 3, so 1 upon y cube. Okay, 1 upon y cube. So this is your integrating factor. Now multiply integrating factor on both the sides. So 1 upon y cube, that is y raised to 4 plus 2y plus 1 upon y cube, x y cube plus 2y raised to 4 minus 4x dy, that is equal to 0. Okay, so y plus y cube, y cube will be cancel out. So 1 upon, so y plus 2 by y cube, x plus 2y minus 4x by y cube. Okay, dy, that is equal to 0. So m1 is equal to y plus 2 by y cube, and n1 is equal to x plus 2y minus 4x upon y cube. So del m1 by del y. Here now you can check whether the given differential equation is exact or not. So del m1 by del y, that is 1 minus in differentiation of 1 upon y square, that is minus minus 2 upon y cube. So minus 2 into 2, that is minus 4 upon y cube, and this is also del m1 by del x. So that is integration of x, differentiation of x, that is 1 minus differentiation of 2y with respect to x, that is 0, and differentiation of 4x by y cube. So 4 by y cube constant, differentiation of x, that is 1. So minus 4 by y cube. Clear? So now your differential equation is exact. Okay, and hence the general solution is integration m1 dx. Okay, integration m1 dx. So here just we find integration m1, that is 1 minus 4 by y cube. Okay, dx, and only not containing x. Okay, so plus we cannot take this term because here is x. We can take this term. So integration 2y dy, that is equal to c. Okay, so what is your final answer? Just I write here. Okay, so integration of 1 with respect to x, that is x minus 4 by y cube as it is. Okay, integration of 1, that is x. Okay, so x minus 4x by y cube, and here integration of 2y with respect to y, so 2y square by 2, 2 will be cancelled, and that is equal to c. So my final answer is x minus 4x by y cube plus 2y square, that is equal to c. Okay, so in today's lecture we discuss about case 1 and case 2 for non-exact differential equation. Okay, so up to this, thank you.